in pink. Okay, so now, what if now, right? We have a Vy. Okay, so the shear stress, I'm going to write in pink. Okay, the shear stress is equal to Vy over Izz, okay, Qzt. Okay, so now if we have a Vy, right? So if we have a Vy, point A and point C will be equal to 0 because there's 0 what? Thickness. Whereas point B and D will have Vy over Izz, right? Qz divided by T. And this one will also have Vy over Izz Qz divided by T. Or we have the last one, the last force, if it's there, okay, if we have it. Okay. Again, these are not there, but I'm just trying to see what if we have stresses or forces in the z direction. Okay, so Iyy, Qy divided by T. So now we have a Vz. Okay, so now we have a Vz. If we have a Vz, B and D will be equal to 0. Okay. However, over here we have our Vz over Iyy, Qy over T, and the same thing over here, Vz over Iyy, right? Qy over T. Okay. Now the pink one are stresses that are not experienced in our question, but if you have to analyze, this is how you analyze. Okay, now coming back to our question now. Okay, so let's focus on the highlighted one. Okay, so this is highlighted, highlighted, highlighted. So in terms of shear stress, right, there's nothing, we cannot make any judgment. Okay, we cannot make any judgment. But before we go there, let's come back to the question is tricky in this way, right? It states that this, okay, if you look at the question, it states that the U point for tension is at 100 KSI, right? So if you were not to understand Tresca criteria that said that the stress Y in tensile and compression are the same, right? You will have picked, right? You will have picked this value. You will have picked this one. If you don't know Tresca criteria, right? You will see down here, Eugene, they only give us what? Tension. So I'm going to pick point A has the maximum tension. Yes? Point C has the maximum what? Compression. Okay? But knowing Tresca criteria, what did Tresca? So Tresca criteria, right? Tresca criteria assume that, okay, he make this assumption, okay? Assume that the yield strength in tension or in tensile and compression are the same or have the same magnitude. Okay. So that is why, for this case, what we are doing now, okay, element C, okay, element C has the highest magnitude in compression. Okay, in compression. Right? Therefore, it is used for the analysis. Okay, so we're going to select element C. Okay, element C is valid because maximum compression. We cannot use this value because no doubt the bending moment is in tension, but the axial load is in what? Compression. Are we all clear? Okay, you have to get this like really clear. Okay, if you don't get this clear, okay, you will say, okay, I can still use element A because I only know the tensile stress. True, right? But again, Tresca assumed that the U in tension and compression are the same. Okay, so you will select element C, right? So this, as I said, I've been going through. I mean, been talking for a while now for this question, right? Is this analysis that is going to be what? Critical. Okay, is this analysis that is going to be critical now? Okay, so now we are now going to apply Tresca now. Okay, so we are going to calculate what is our stress state for element C. Okay, so I'm going to copy this diagram. Okay, this diagram is important to me or to us. Anyone, any questions so far? I know it's a lot to take in. Okay, anyone, any question? No, I did not see anyone typing any remark. Right. So we are going to look at element C now. Okay. So I'm going to draw element C. Right. So if we view this in this way now, so this is my X. Let me get rid of this. So this is our X. Sorry, our yeah, this can be our X. And then this will be our Z. Okay, so we are viewing it from the bottom now. Okay, so this is the shaft. Okay, so this is our shaft. This is our element C. Okay, so we know that over here, this is our torque in the X direction. Okay, so the torque is going to push up that way. Okay, so we are going to have px, right? And then we know the moment is going to be compression, right? We are aware that we're going to have a compression. Okay, so now if we were to draw how the element, so if based on Tx, right, which is inducing a shear, the element will deform this way. Okay, the element will deform this way, right? So why the element deform this way? In torque, there will only be deformation if you lock this surface, right? So what I'm trying to say is this. When the shaft is rotating, it will not fail in shear. The failure will occur when all of a sudden this end, right, stops. Okay, you resist the rotation. Okay, then you get that type of deformation. So when that's the case, if we look at our deformation now, based on our deformation, right, this is how the element, the shear will act on our element. Okay, this is how the shear will act on element. And then we have our, and this is our stress in the x direction. Right, we have stress in the x. It's going to go into compression. We know about that, and that is our shear. Okay, so the shear. So if we were to, I'll try to draw this on a 3D now. I'm shooting myself now. So in 3D, so we are drawing from under the, okay, it might not turn out well. Okay, so if I were yeah, I'm not looking for this. Okay, so the shear will go in this direction. Right, the shear will go in this direction, and then this is our stress in the x direction. Okay, so if I were to draw 3D or our transformation now, so this will be our x. Okay, sometimes I make life difficult for myself. This is our y. Okay, and then this is our, wait, go on. Yeah, and then this is our z. I'm trying to rotate. Yeah, this is our z now. Yep. Okay, so that is our z now. Okay, so if we were to look at the intersecting plane, right? So the shear, the intersecting plane is x, z. Okay, so if I were to draw dotted line, right? So our shear, we have another shear component over there. We have a shear component here, shear component here. Okay. So now from here, you have to now sketch. Okay, you have to now sketch where our stresses are acting, or not stresses. Sorry, I take back that word. Now we have to know, right, what is our mole circle. Sketch how our mole circle look like. Why we have to sketch how our mole circle look like? Because we don't know which condition we are in. Okay, we don't know, is it when one of the principal stress is equal to 0 and the other can either be positive or negative, or when the principal stress are both what, positive or negative. So we have to identify. Okay, we have to identify which one we should use. Is it that simple that we can use stress max divided by 2, or we have to find stress max minus stress mean divided by 2? Okay, so now we are going to sketch. Okay, we're going to sketch. So from here, we know that stress x, right, from this element down here. Okay, I'm going to copy this element. I'm going to come here. So we know that